All right, let's dig right into it. I gave you the law of sines and cosines just to remember what those are. We may need them today, possibly. Remember what it's used for. To find any side or angle in any type of triangle. Does not need to be a right triangle. So if we come to that point today where we're like, we need to find this angle or we need to find this side, and it's not a right triangle, probably need to use sines or cosines. So that's why I've refreshed your memory there. All right, no new theorems today. Everything from yesterday is going to be applied. So let's start with 1, find the value of x. What's x in the diagram? That's a chord. Yep, and what do you notice? What about the line segment that's a length of 2? It is bisecting the chord because it's part of a diameter. That's the theorem we went over yesterday. Diameter perpendicular to chord bisects it. Great, and then I just threw this little bad boy out here. That's got a length of 3. That's a what? Radius. All right. This is very similar to the one I just went over for homework. You can add your own line segments in the problem because right now you're not going to find x based the way I drew this. All right, you're not going to be able to find x. Any suggestions on maybe what I want to do here? Or you know what? Talk to your group a little bit. I want to give every problem and say, hey, anything I can add in? What's our plan here? All right, instead of me saying, you do this, you do this, you do this. All right, talk it over with your group here. What's a suggestion here? Okay, suggestion. Here we go. Going to go to numbers now. Here you go. 13. Suggestion for me.
We drew in another radius.
Where?
To connect the chord and the center C.
Yep, got it. How that radius I drew in, how long is it?
3.
Every radius I draw in will be 3 up. And then what was your plan to find x? Well, Pythag won't find x. Pythag will find half of x. So I got 2 squared plus b squared equals 3 squared. I got 4 equals 9. What do I have there? B squared equals 5. So half of the chord is the square root of 5. So what can I do to find x? Multiply it by 2. So I have 2 radical 5, but the directions do say nearest tenth. So we go to the calculator. 2 radical 5, the same as, what do you got for me? 14. 4.5. I got any units on here? Nope. So I won't provide any on the answer. 4.5. Everyone all right? Pythag, not too bad. What happens if Pythag's not available? Okay, here we go. Next one. Ooh. Find that chord length. What's the 12? Radius. So if you decide to draw in another radius, it will also be 12. And then I gave you the arc right there is 120 degrees. The arc measure, 120. Whew. Can you make a triangle for me? Can you make a triangle? Draw on the other radii, which has a length of 12. All right, let me draw that triangle out in the circle, and maybe you can put a little more detail on it. I got 12. I got 12. I got x. Is there anything else you could put in there based on what we've covered this unit, Al? The central angle up in the circle right here also has to be 120. How does he know that? Central angle is always equal to the arc measure. Central angle always equal to your arc measure. So if that was the arc was 120, so is the central angle. All right, here we go. It's not a right triangle, is it? It's not a right triangle, but it is any type of triangle, so I can use sines and cosines. Let's see which one we can provide. What type of triangle is it, though? Isosceles. Can you fill in more degree measures for me? I got 120 there. It's isosceles, so the angles across from those sides must be congruent. They're going to be 30 and 30. Looks like I can use which law right now? Trick question. You can use either one. All right. If I can use either one, I prefer probably to use law of sines. I don't know how you guys feel. Okay, quick review. Law of sines. Here we go. Number 3, I need an... Nope, not here. Good call. Let's try out 29. Ooh, give me a side length. Over. What's the angle across? 30, but we don't put 30. Sine of 30. And on the other side, x over sine of 120. Again, you could use law of cosines as well. All right, you could use law of cosines here. I'll give you a second, cross multiply. When you get to it, we're still going nearest 10th, still going nearest 10th. 7 when you get to it, nearest 10th. 20.8. No units, nope. So yeah, you could use Pythag if it was a right triangle, but this one wasn't, so we had to use law of sines. Everyone okay so far? It's getting a little tougher because the algebra is tough. Anything you want to ask? Because it is going to get a little more difficult here in 3. Okay, here we go. Radius, measure of the arc. Let's do radius first. I think that's the easier one. Let's find the radius first. Radius, here we go. None is drawn in, but can you draw one that you could find? Can we draw a radius in there somewhere where we could find it? Either from C to B or C to A? What circle theorem can be applied here? From yesterday, what circle theorem can I apply? 18, which one can I apply? I guess this 24 is not helping me. If it's perpendicular, yep. So I have 12 here. So I think we can do a little Pythag to find the radius. 5 squared plus 12 squared equals r squared, or c squared if you want to keep it in there. When you get to that, let me know. 26, when you get to that, let me know. 13, watch your mouth. Feet, nice job. Okay, I got 13 feet. All good, because now we need everyone on board now. Find the measure, not the length, the measure, meaning in degrees. How many degrees is it from A to B? Woo! So how many degrees in arc AB? And I'm telling you, it's this one right here. Woo! Need a little help, kids, huh? Or have to all put our heads together for this one. I didn't say you couldn't use them. I just wanted you to be aware that we're not solving for L here. We're solving for that. Okay. That's all I wanted to make clear, but whew. Anything? What's up, Maggie? Okay, before we get to that, yes, we can. Before we get to that point, you got to get me a triangle, though, that I can use. And why I would want to use law of cosines. Because you're at the finish. We just have no idea how you got there. What path you ran on. So you go A to C. Because we know that's 13. We just found that's 13. Hey. Oh, whoa. Okay, hold on. Measure of the arc is always the same as the what? Central angle. Correct. Yes? So right now, the measure of arc AB is the same as the measure of angle what? Angle ACB. So if you can find the measure of ACB, that's the same as the measure of the arc because it's the central angle. Let me draw this triangle out. Here's what we have. A, B, C. We have 24, 13, 13, and you guys want to find this angle right here. Because if you find the central angle, you found the arc measure. And Maggie is right. This is a law of cosines question. First of all, do you see why you can't use sines if anybody wanted to try to use sines? Because you only have, what's the other angle you're going to put in? I have no idea. Okay, so it is going to be law of cosines. Here we go. Let me just write it out. And then you guys can refresh your memory about what to plug in. We always plug in side across from the angle, which would be what in our case? 24 squared equals 13 squared plus 13 squared minus 2 times 13 times 13. Cosine C, cosine X, whatever float in your boat. Yep, a little difficult here. This is some true honors level stuff here. Love it too, because we get to review some old stuff. What do you got? 576 on the left. Anybody remember I always made a fit about this, about the right side here? You cannot combine all three. Remember that. You can combine 13 squared and 13 squared, but not 2 times 13 times 13. Okay, because it's connected with the cosine X. So go ahead, 13 squared plus 13 squared. 338 minus 2 times 13 times 13. 338. You cannot subtract those. And even if you try to subtract them, you're going to be 0, and you're going to be like, what's going on? And you'll be correct. All right, turn it over to you guys. If I can't combine them, what's my next move? 5.
Subtract 338.
Darn right. Darn right. Minus that 338 over. And to my math, I got 238 here. And what's left on the other side? Don't drop the sign. Negative 338 cosine X. Yep, we're rolling, having fun. Here we go. Next up. 11. Next move. Not here. One job. 17. There wasn't a yes or no question. Next move, Teddy. That's what I want to know. Next move. Is that a question? Yes, be confident. By what? Yes. Teddy, have some confidence back there. Come on. You're a superstar.
Yeah, you play tennis.
Cosine X, I didn't leave that as a fraction. Sorry. whatever that comes out to be reduced. That's not my answer. I need to find the angle, right? There's one magic step we have to go to now. One magic step up here. I need to do what to find the angle? 4. Come on, Emma. Darn right you do. Go ahead. And then the angle to the nearest tenth. No. I just want you to do inverse cosine for me and tell me what the angle is to the nearest tenth. No pressure.
I get 134.8 degrees.
Correct. Good job. All right. That's the central angle, which also means it's the arc measure. All right. Anything you want to ask there, because I'm going hands off for the next 5 minutes. Okay, I'm coming around. I'll help you guys out. Talk it through in your group. Number 5, find the radius and find arc AB to the nearest tenth of a degree. Before I move on, because we're going on to something totally different here, ask away. Anything. You're going to have another one of these tonight. Maybe not law of cosines, but you have to decide between sines and cosines on the one tonight. Ready to go. I don't know how long, how many days, how many months it's been, but yes, we can welcome back. No. Our proofs, yes. Here we go, back in business. Please do not forget everything we've gone over. All right, I know you want to use circle fact, circle fact, circle fact, but you'll see right off the bat here, we can use some old stuff right off the bat. All right, first off, I got arc AC and arc CB congruent, so you can mark them with hash marks if you'd like. Those two arcs are congruent. We are asked to prove the triangle's congruent, so real quickly, good old review, the 5 methods I have available to me here to finish this proof. Side, side, side. Side, angle, side. Angle, side, angle, where the side is in the middle. Angle, angle, side, where the side is not in the middle. And then everyone forgets HL only in a right triangle. All right, let's get to work here. Circle facts and other theorems from this past, what are we on, 25 weeks? All right, I'll open it up because there's multiple ways of doing this. You can either use the arcs being congruent and get something from there or something on your own. Dan, here we go. There it is, everyone. There it is. OC, congruent to itself. Back at it again, reflexive. Perfect. We got a side. Need 2 more pairs of something. Sinead, you're up. Okay, I'll go there. Angle AOC is congruent to angle COB. Need some help, though, with that one. Need some help. That's going to be a new fact. Need some help. What was given? What did I give you? Ready? Just like we wrote yesterday, congruent arcs imply, what did Sinead just give us? Congruent, what are these? Central angles. There you go. That's how we write it. Tell me what you're given, and that implies what you just wrote. Nice. I got a reflexive side and a couple angles there. Hi, Maggie. AO congruent to OB. There we go. We used this one yesterday as well. What are AO and OB? Radii, but I can't write radii are congruent. That's not true. In a circle or in the same circle. In a circle, radii are congruent. And as far as you guys have done this, that should be enough. What method's staring you in the face now? Side angle. Side. Oh, it's been so long. Thank you, Orion.
Could we say that AO and OB are radii even though it's not stated in the givens?
You don't need to say that. I don't need to because it says it's circle. Oh, that tells me it's the center, so that has to be a radii. You don't need to state that. All right. Also, anyone see you could have done side, side, side? How do I get BC congruent to AC? Congruent arcs imply what are these? Congruent chords from yesterday, all right? So you could do side, side, side. We all good? It's nice to get back into it, right? One more? Yeah, you got it. One more. Yep.
Dang, wasn't
Whew. Ooh, how about this now? Prove the angles congruent. Well, they're not going to get congruent until triangles are. Yep. Let's see. Radius OC is perpendicular to chord EF. All right, everyone stop, because you're going to make a mistake here. Happens every year. First, let's get the triangles congruent. Anything you want to spit at me here to get them congruent? Dewey, one thing? I'm glad you did that, because I can't write that yet. I can't write that. It is going to be true, but not right now. Here's what you're probably saying, because you know what? This radius is perpendicular, so it bisects, right? But that, hey, everybody, that theorem does not say the two little pieces are equal. The theorem says the chord is getting bisected. So that's what's got to be written up here. Name the chord up here. EF, and name what's bisecting it. So I need to say OC bisects EF. The theorem does not say the two pieces are equal. The theorem says the chord's getting bisected. Now it's diameter. This is what we wrote a couple times yesterday. Somebody finish that. Diameter, perpendicular to a chord, bisects the chord. Does everyone see how to properly use that now in a proof? You cannot say the two little pieces are equal because of this theorem. Diameter perpendicular to chord bisects the chord. Now, going back to Dewey, if we wanted to write EW congruent to WF, we can, but now what would be my reason here? Thank you, Orion. Definition of a bisector. Whew. Everyone see that? It's going to happen tonight again. This theorem is to say the chord is getting bisected, not the two segments are equal. All right, what else you got for me? That's only a pair of segments, only a pair of sides. Meg!
Angle EWC and angle FWC are right.
Remember these days? Yep, angle EWC and angle CWF are right angles. Anybody? I know it's been a while. Perpendicular lines form right angles. And then we need to say right after that, they're congruent. This was good times. EWC congruent to CWF. What was that reason? Oh, yeah. See? It's like you never left. We need one more pair. Tough pair up here. Jasmine. Yeah, CW. CW congruent to itself. Reflexive. Triangles are congruent. Triangle CFW is congruent to triangle CEW. Kids, what method you have there? Side angle side. And talk about being a Y here, huh? Let it roll off your tongue. CFW congruent to CEW. CPCTC. Last thing, announcement-wise, something that usually doesn't happen will happen tonight. I am not posting an answer key. I want to see what you can do on your own, and then tomorrow we're starting class. What'd you get for an answer? What'd you put in your proof? Okay? So you have one algebra question and 2 proofs tonight. No answer key. All right? I want to see what you can do on your own. All right?